if a moon rover finds a rock on the moon and determines its weight to be W, so force is equal to gravitational acceleration, mass 1, mass 2 over r squared. But if we're talking about weight, weight is the force that anything is attracted to a planet with. The radius of the moon is r, so we'll put a capital R in there. A space team picks it up and takes it to planet Alpha, where the weight of the rock is now 8W. 8W is still equal to G. M1 is the same. It's the object, mass of the object, okay, whatever it is. M2, obviously the mass, we want to know alpha, the radius of the planet is half the radius of the moon. And the mass of the moon is m, so let's change this to a capital M. Then the mass of the planet is what? So I'm going to say x times m. Maybe it's going to, that x will turn out to be a half. Maybe it will turn out to be 4. Maybe it will turn out to be 2. I don't know. But the point is, I'm saying there's some coefficient to that mass of this new planet. So let's rearrange things a little bit and go that is equal to, I'm going to take the x out. I'm going to leave the g in, the m1 in, and the capital M in. And I am going to square this half, which is a quarter. I'm going to take the quarter out. And I'm going to square r squared. Now this expression over here looks exactly like that expression over there. So 8w, I'm going to just go up to the top, 8w is equal to, this quarter at the bottom really is 4 at the top, is 4x g m1 m over r squared, which is 4xw. Now, if I'm left with 8w is 4xw, what must that x be? That x must be a 2. So therefore, this is twice the mass of the other planet, or of the moon. An object x of mass 5 kilograms is placed at the center of a circle with a radius of 200 millimeters. Second object y is double the mass of x and is placed anywhere on the circumference. The force that x exerts on y, so it's a force of attraction, so we'll say y moves towards x. What is the magnitude of the force that y exerts on x? These two exert exactly the same force on one another. It is an equal but opposite force, so there's your answer, as easy as that. Planet P has a mass m and a radius r. Which one of the following planets will have a gravitational field strength which is 4 times greater than planet P? So, if I'm taking a look at those two, I'm going to say that over here, I want a g that is 4 times. Now remember what g is. It's just mg. So in other words, it is the force. So we want the force to be 4 times greater. So this would have been force is equal to g, m of the little object, big M of the planet, radius of the planet squared. Let's try over here. I'm going to do A first, and that is going to be the new force of A is equal to g m 2m over r squared. I'm going to bring that 2 to the front, and that means that it's 2 times the original force. I want it to be 4 times the original force. The next one, I'm going to say the force of B is equal to g m 2 r squared. That becomes 4r squared, and therefore it is a quarter of my original force over here, and that is not 4 times. The next one is going to be force of C is equal to g m over a half r all squared. That half r becomes a quarter r squared, and a quarter in the denominator turns into 4 g m over r squared. That is 4 times the original force. So that is your correct answer. And if I went to the trouble of doing this one over here, I would land up with an 8 at the top. It wouldn't land up being 4 either. So that is your correct answer. You need to go through that process carefully. The gravitational force of attraction between two asteroids is F. The distance between the centers is now halved. What is the size of the new force? So my original force is G m1 m2 over r squared. My new force, new, is equal to G m1 m2 over half of r all squared, and that is going to be a quarter of r squared, and a quarter in the denominator turns into 4 times the original force. So your correct answer is A. Calculate the gravitational force of attraction between mass of 124 kilograms and that mass that are 15 meters apart. It's a simple substitution. F is equal to 6,67 times 10 to the negative 11 multiplied by 124. Yay, it's already in kilograms. 244. Yay, it's already in kilograms. 15. Yay, it's already in meters. Don't forget to square it, and you land up with that answer. 2 space capsules of equal mass are put into orbit 150 meters apart. The force between them is 2, 0 times 10 to the negative 7 is equal to 6,67 times 10 to the negative 11. They are identical massed, so it's m times m. Mass 1, mass 2, they're the same. That turns into mass squared, not 2m. And now I have got a distance of 150 meters. Do not forget to square your 150. Rearrange that. Don't forget to square root the mass, and you land up with 8,2 times 10 to the power of 3 kilograms.